Hello, everyone, and welcome to the operating series of lectures. Tonight, we're privileged to have with us Paul Stoetzer, N8HM. Paul has given many of these lectures in past years. Um, he is associated with the AMSAT Corporation, Executive Vice President, and he is going to be talking first about satellites, satellite communications by amateur radio communications by satellite. The second topic is another very popular topic, and that is operating portable, operating in the field, operating PODA. And he also has agreed to add some uh, information about logging PODA. It turns out, I found out last week, and I'm
Okay,
sure
don't
Paul
don't
is.
get ahead of yourself. There'll be two separate recordings for this.
Okay.
So people
Oh,
watching the recording, don't fast forward to the middle of this because it'll be a separate recording.
very good. Uh, yeah, so for those of you who are live, stick around for the second part. As I learned 2 weeks ago when I did logging, that there are some very special capabilities available for PODA logging people too. So, Paul, without any further ado, let me turn it over to you, and I'm going to sit back and enjoy your presentation. Thanks for showing up tonight and helping us out.
All right. Good evening, Roll. Thank you very much for that introduction. Pleasure to be here. I think this is my seventh one of these operating classes. The first was on site at the National Electronics Museum, and then obviously 2020 began the online version. So it's great to be able to share these sessions with everybody in the area as well as outside the area from Zoom. So. As Raul mentioned, my name is Paul Stoetzer, N8HM. I am AMSAT's Executive Vice President, and we're going to focus today on getting started on FM satellites specifically. Uh, to go through a whole satellite presentation would take a lot longer than we have, so I'm going to just focus on the basics that you can go and listen to a satellite tonight. In fact, as I'll discuss in a slide later, there's an ISS pass over for those of you who are in the local area. The ISS will be passing over shortly after 10 p.m. And if you're interested, I would certainly encourage you to go outside and listen on your HTs to the ISS repeater. All right. So again, we're going to specifically focus on FM satellites, and we're going to talk about what equipment do you need, how do you know where the satellites are, how do you know what frequency to be on, how do you track the satellite, what do you say during a satellite contact, and finally, we'll talk about some tips and best operating practices and where to find some more information. So, what's the big deal about satellites? Well, they are a great entry point for new hams. Anyone with a technician class license is able to use any amateur satellites. And in some cases, you can make just as many contacts with a $30 station as someone who spends $4,000 on theirs. That may be slightly exaggerated, but I have seen photos of people using, or videos of people just using a Baofeng and a homemade antenna and working a satellite from horizon to horizon. So it is certainly possible. This gives you the opportunity to earn awards. Worked all states in DXCC. A little difficult from this area, but certainly VUCC, which is 100 grid squares on satellite, is certainly a very doable, very doable even for someone with an HT and handheld antenna. So again, it's a great entry point for new hams, but there's also more to offer for the seasoned hams as you begin to get more experience with satellites and want to progress with that aspect of the hobby. There are linear transponders where you can have a conversation over 20-minute pass with somebody, 12 to 20-minute pass. There are satellites that have digital communications transponders, and there are opportunities for microwave as well. In fact, there was a satellite that was just launched that has a 5.8 gigahertz beacon. So being able to receive that and track that is certainly something that is 5.8 gigahertz in low Earth orbit, has a ton of Doppler shift, and you need to be very accurately tracking it with a dish to receive that signal. So that is something that would take some equipment and experience to do. One thing about amateur satellites, I know we've had certainly a few days this past couple of months that the band conditions on HF have been pretty bad, but amateur satellites, as long as the satellite is operational, the band conditions don't matter in general. There are some edge cases with that, but in general, solar flares and band conditions don't matter. It is if the satellite is on and operational, you're going to be able to make a contact through it as long as you have the your equipment all set up correctly. And there's really nothing more thrilling than making a contact through a 4-inch cube-size satellite hurtling through space at 17,500 miles per hour with just a 5-watt HT. Obviously, everybody knows Hamvention was this past weekend, and we did a bunch of demos near the AMSAT area. And kids always get a kick out of talking about the satellite and hearing the voices. When you're talking through the satellite, hearing your own voice come back, and it's going up through the satellite and coming back, and you're hearing your own voice, and then hearing other people's voices. It's always something that is interesting to hear. So again, what equipment do you need? How do you know where the satellites are? How do you know what frequency to be on? How do you track the satellite? What do you say? And then some tips and best operating practices. So let's talk about the first amateur radio satellite, and let's just briefly talk about the short history of amateur radio satellites. So the first amateur radio satellite was called Oscar 1, and it was launched on December of 1961. This was only 4 years after Sputnik. And in fact, Oscar 1 was the first satellite that was not commissioned and built on behalf of a government to be launched and to operate. So amateur radio in space goes all the way back to the very beginning of the space age. Since then, more than 100 amateur radio satellites have made it to orbit and been successfully operated. However, satellites don't last forever. They have limited battery life, orbits decay, and they re-enter the Earth's atmosphere. Parts fail due to either thermal conditions or radiation. So the number of currently operating satellites is about 30, but there are fewer than that you can actually communicate through. Types of amateur radio satellites do include what I mentioned with linear transponder satellites. On those satellites, you're going to use single sideband, a CW, or as a growing number of people are doing, are making FT4 QSOs via linear transponders. Linear transponders take a section of band, either on VHF or UHF, and retransmit it on UHF or VHF. So you're talking about taking a slice of 20 to 100 kilohertz of 435 or 145 megahertz and retransmitting that on that entire section of the band on 145 or 435 megahertz. So those are used, again, those will retransmit any signals that are sent to them, but because they are a shared resource, anybody who's using a full duty cycle mode like FM would tend to really negatively impact the rest of the operators on the satellite. So by convention, they're limited to single sideband CW use and some limited digital mode use as well. The other types of amateur radio satellite, and the one that we will focus on tonight, is FM repeater satellites. Then there are digital satellites. Most of these have packet uplinks and downlinks. Most of these satellites actually use the APRS protocol, AX25, and it works essentially like a digipeater in space. So it takes the same type of APRS packet and relays that back to Earth. You can make QSOs through that, or just digipete your position. And then finally, a lot of amateur radio operators just like collecting telemetry. I know several amateur satellite operators who have quite extensive stations and listen quite frequently to amateur radio satellites and decode telemetry from all sorts of satellites and never make a contact on their fancy and expensive stations. They just like the challenge of receiving the telemetry and looking at all the values that get recorded, or helping out the builders of those satellites and sending the telemetry in. Additionally, one thing that I don't mention here, there are actually a number of satellites that transmit SSTV images. That's becoming more and more popular, kind of brought on by the popularity of the ISS sending SSTV. And so there are also a few satellites that are sending that too. And there's information on the EMSAT website about those satellites. All right. See here. Next slide here. Okay. So let's talk about what equipment you need. So for the radio, in general, you want a dual band transceiver that can simultaneously transmit and receive VHF and UHF at the same time. This is what we call a full duplex radio. The alternative is to have two separate non-full duplex transceivers to give you full duplex capability, because if you have one radio that's on VHF, one radio that's on UHF, and you have a full duplex radio just in two separate radios. The other option is to use a dual band VHF UHF transceiver and use a receiver, an SDR receiver, a multi-band receiver, such as probably one of the best choices is for this purpose is the AirSpy Mini, or the SDR Play has. There's a number of these out there, but if you have an SDR coupled with your non-full duplex transceiver, you have all the components that you need. Of course, not all dual band transceivers are full duplex. Not all advertised full duplex transceivers are truly full duplex, and not all receivers are created equally. One thing about the SDRs, I know a lot of you on this probably have RTL SDR dongles that are $30 on Amazon, and those won't generally don't have an adequate sensitivity or filtration at VHF or UHF to do very well on satellites. I have tried them out. I have used them. I've made contacts with an FT817 and a SDR, an RTL SDR, in fact, but it is not a great experience, and you don't hear the satellite from horizon to horizon. So if you do decide to go this route, a good SDR, such as an AirSpy or potentially some others, but I really haven't tested too many. The FunCube dongle I don't believe is available anymore, but those all have good characteristics. All right, so let's talk about some specific models of radios that are full duplex. Excuse me. All right, so there are a number of full duplex FM handhelds that work for UHF and VHF, as well as VHF and UHF. Unfortunately, all but one are no longer available. ICOM had a couple of models. Kenwood had a few models, such as the THD7. The THD72 is the most recent Big 3 radio that can do full duplex. And Yaesu had a number of radios back in the FT470, the FT530. In fact, many people consider the FT530 to be the best full duplex FM handheld that's ever been released. So if you find one of those, or you have one of those, that's a great radio for FM satellite operation. One radio that came out in December that shows a lot of promise, and I've seen some videos demonstrating it, and I do have one, but I haven't had a chance to test it out yet. But I've seen a video of a guy using his, and it worked great. Is the Anytone ATD890UV. This radio is also available from Bridgecom as the Bridgecom Maverick. I think it's got a BTEC brand as well, but it's marketed primarily as a DMR radio, but it also has the ability to do full duplex, and it appears to do it well. Now, the issue with some of these others that are in this last section here is the when you transmit on VHF, the UHF downlink gets blasted out by the third harmonic of the VHF transmitter. So, such as the Anytone Terminator, some of the ICOM ICW32s, the Woshons, and the Elenco DJG7T. If you find any of those, or if you have any of those, and you transmit on VHF, you won't really hear yourself well on UHF. Maybe when the satellite is at a high elevation, it's close to you, and then maybe you will, but they are not. They're not good for this purpose. However, there are a number of FM mobile radios that are capable of operating. I believe ICOM still has the IC2730 in production. The ID5100 is being replaced by the ID5200. Those should both do it, although the ID52 hasn't been released yet. So obviously haven't seen any tests of that. Kenwood's, the D700 line has always been full duplex. The TMD750 is also supposed to be full duplex. So that radio will, of course, should work for it. But again, that hasn't been released yet either. So we will see. I forget which of the Yaesus on this list are still in production. I should have gone through and updated this, but like I believe the FT, there are a few other Yaesu models that are in production that can do full duplex as well. So if you have one of the FM transceivers, FM mobile radios that can do full duplex, that's an excellent. Excuse me, my voice is. I need to get through a few more hours of this, but just got back from Dayton, so the voice has not been well rested over the last week. Okay, so Yaesu has a number of models as well, and all three of them do. So if you have any of these models, one advantage of mobile transceivers compared to handheld transceivers is there's more room for appropriate filter circuitry. So any of the full duplex FM mobiles should work fine for any FM satellites. All right, so now you're talking to the satellite transceivers. These, of course, all work great for satellite. They're designed for it. If anybody has an ICOM IC820, I would caution that it has some usability concerns. But the ICOM series of satellite radios are all fantastic. 820, 821, 910, 970, 9100, and the current production model, the 9700. Again, they all work fantastic for satellites. I did all of the demos at the AMSAT booth, outside the AMSAT booth at Dayton this past weekend using an IC821. Worked well as can be expected in the RF area that is Dayton. That makes satellite reception quite challenging when you're everybody, 30,000 of your closest friends are all transmitting on their HTs. So plus demo stations and other things. So it's a challenging RF environment. The 821 did well. Now, just a note about availability of some of these radios. My ICOM 821, I got it on eBay a couple of years ago it was just about $400 plus shipping, with the caveat that mine is the Japanese model, which means that if you're looking for a radio that does FM repeaters in the area, in this country, then that's not a good idea because it only covers 144 to 146 megahertz and 430 to 440 megahertz. So it's limited use cases, but for either VHF, UHF contesting with single sideband CW or satellites, that's really all you need. So if you don't want to work repeaters, something like that is not a bad way to go. problem on eBay is that there are a lot of Japanese-made radios there, and if anybody has not mentioned this before, be very careful when you are buying a Japanese-made radio because Japanese regulations are strict, and the radios are limited to the Japanese band plans and usually cannot be modified to transmit outside of the Japanese bands, which are again less or more limited than the bands in the U.S. So that's not specific to satellite radios. That's just something I have seen and have heard of many hams making that mistake of buying Japanese radios and not understanding that they generally can't be easily modified to transmit on the entire bands. So for satellite radio, that works out. I got a 821 that was inexpensive, in great condition, works well, and does what I need it to do. But just be cautious of that in general when buying radios because eBay is flooded with what look to be great deals on some radios, but then it's the Japanese model. So now Kenwood had the TS790 and the TS2000. The TS2000 has a minor annoyance that SO50 is our most active and FM satellite, and there's a birdie that interferes with its reception, but it is still an excellent radio. And the TS2000 is a shack in the box that covers HF, VHF, UHF, and you can find them for pretty good deals. I think I saw one at the Dayton flea market for $850 or so. That was in pretty good shape. So that's something to look out for. Yaesu also had a few satellite transceivers. I wouldn't go with either the FT726 or 736. First of all, the 726 didn't come standard with the satellite module, so you'd have to ensure that it has the VHF and UHF band modules as well as the satellite module for that to work. The FT730 and plus the 726 can't be computer controlled, so that's going to be a disadvantage if you want to do computer Doppler control in the future. The FT736 also has only unidirectional computer control, which means that you can't tune the radio and have the computer respond to it. So wouldn't recommend a 736 either unless you have one or have one gifted one or find an excellent deal on one. However, the FT847 is still a fantastic radio. Again, like the TS2000, it's a shack in the box, HF, VHF, UHF. And in contrast to the TS2000, it's a smaller radio too. And it's really a small package that does it all. So, if you have one or have an opportunity to get one at a competitive price, I see them go again at Hamvention. They're going in the $800 range. So they're not a bad deal because you get full HF, VHF, and UHF radio all in one box. It's really a shame nobody is making one like this. That nobody's making one that has the full duplex satellite capability anymore. Obviously, there are plenty of other radios, as we'll discuss on the next page, that have all modes and stuff, but and all bands, but they're not full duplex satellite capabilities. So some of these include that include all VHF and UHF bands and as well as all modes. Include the ICOM IC706. Mark II-G has VHF and UHF. The earlier 706s do not, but the Mark II-G has both VHF and UHF. The ICOM 7000, the 7100. The 7100 is likely to be discontinued because most people believe that ICOM has been teasing its replacement over the last week or so. But these are all the ICOM radios that do all the bands. Yaesu, of course, has had a number of them: the 817, 818, 857, 897, 991. I believe the 991A, I don't believe there's official word, but that has been rumored to be discontinued as well. So the Yaesu now has the FTX1F that does all bands and all modes and would make a good satellite transceiver. And then, of course, ICOM also has, I don't believe I mentioned the 705, makes a great half of a satellite station. Now, you probably aren't going to get the ICOM IC905 for this purpose, but if you do, again, it does do 2 meters, 70 centimeters, as well as 1.2 gigahertz, 2.4 gigahertz, 5.7 gigahertz, and then if you buy the optional add-on module, 10 gigahertz. So that'll get you quite a bit, but it will work. The 2 meter and 77 centimeter portion will, of course, work for satellites, and then the microwaves can also you can receive some of the new microwave satellites as well with that. Tom, did we have a question or roll? I forget who was.
No questions so far.
Okay, all right, thank you.
Yep.
All right, so what I have in this photo here is two Yaesu FT817s. The satellite community affectionately calls that a Yaesu 1634, or of course, if you have two 818s, it's a 1636. That really is a fantastic pair for satellite operation. I've extensively used a pair of Yaesu FT817s for portable satellite work. Again, it's a shame that this form factor has been abandoned by Yaesu and, well, really by any manufacturer. Of course, there's no room with such a small screen for the fancy waterfall and the displays and touchscreens that everybody wants. But when you're looking for portability, that those two 817s put together in a pouch around your neck or around your shoulders really is impossible to match for a versatile satellite setup for portable satellite operations. All right, so now we've gone through transceivers. Let's talk about antennas. So realistically, the key to reliable satellite communication is to put together the best receive station you can, which starts with your antenna. Now, there are many videos on YouTube that show people receiving satellites or even working satellites with an HT and a rubber duck. That can work in certain circumstances. I made 4 QSOs on SO50 when standing on the shore of Lake Michigan a few years ago with an HT and a whip and a earpiece. But again, I was standing on the shore of a large lake that had absolutely clear horizon. I was nowhere near any noise sources, so I was able to hear the satellite pretty much from horizon to horizon, even with a whip, and actually make contacts with it. But I would never recommend that you try that. It's a recipe for frustration if you try it too many times. So the best antenna for satellite work is a small beam that's pointed at the satellite. The gold standard for these portable satellite beams is going to be arrow antennas. They are they're the best option for this at this point. They have a couple of different models, but the basic 146-43710, which has 3 elements on 2 meters and 7 elements on 70 centimeters, is a fantastic option for working satellites. Elk also is a decent antenna. It's a much better 2-meter antenna than a 70 centimeter antenna, though, so you will not receive any 70 centimeter satellites as well with the Elk antenna. But you don't need to. You don't need to. You certainly don't need to buy an antenna. You can always build. There's V2ZAZ. ZAZ has plans for an Aero style homebrew, and then Kent WA5 VJB has his cheap Yagi that works well as well and can be built with only a few dollars worth of parts. So this is the Aero 2. Again, that's the 3 elements on 2 meters, 7 elements on 70 centimeters. Antennas are at a 90-degree angle. Each has a BNC connector. There's the Alaskan Aero model, which has 4 elements on 2 meters and 10 elements on 70 centimeters. But it will give you a workout if you want to use that one-handed. It is very front heavy. It's not very heavy, but since you're holding it at the end, it's just very front loaded and very it puts a lot of torque on your wrist. So, and it's generally not necessary unless you're looking to do extremely low elevation passes, and even then, depending on your environment, it's probably not necessary. I would always recommend getting the split boom because the split boom does add a couple of ounces. When you go on the website, you'll see the differences, but you can actually take it apart and put it into a bag about 30 inches or less than 30 inches long, so it'll fit in the suitcase. The options also include a built-in diplexer. Now, if you want to use one radio, that is a good option. But oftentimes, if you want to use use two radios, if you're going to use two radios or a radio that has two separate VHF UHF inputs, like say like a satellite transceiver, then you don't need that duplexer. You just you don't need to pay the extra money for that. Again, the elk antennas, they have a dual band log periodic. It has a single SO239 connector, or I believe you can get it as an N connector. You used to be able to. I don't know if they still offer the N connector. I think I saw somewhere they might have discontinued that because it wasn't as popular. But this one, of course, has the feed point at the front as a log periodic, so it's a little different. And you don't need any sort of diplexer. Well, they refer to it as a duplexer, but both Arrow and Elk do, but it's really technically a diplexer. We don't need to get into that. And so this has a single feed point, and you just if you have a full duplex radio, you just plug it right into your radio, like is shown in this picture here. So this is the V2ZAZ Arrow style antenna. It shows you how to, again, this website shows you how to build a portable antenna in just a few dollars in parts, and that'll work just as well as an Arrow, but it won't be as easy to take apart and put back together. Similarly, the W5VJB cheap Yagi antenna is also something that is very easily built with just a few common parts, and that also will perform quite well. He has a number of different sizes of it available, and again, you can put that together and it'll work just fine. So one thing you'll need in addition to this antenna is coax. You'll need coax obviously to connect your antenna to your radio. So your antenna may come with coax like the diplexer on an Arrow antenna, or you may have to supply the cable. Technically, any 50 ohm cable will work, but you'll get the best performance for anything. I do recommend LMR 240 Ultraflex or ABR 240 Ultraflex for your antennas and jumpers. This is, even if you're talking, the numbers don't really bear it out, but I have found a difference using 6 feet of RG58 and 6 feet of LMR 240 Ultraflex. Now, maybe I'm imagining it, but a lot of people have said the same thing, that that it really does make a difference, even though it shouldn't by the numbers. So use good coax, especially if you're going to be building a home station and have long cable runs. You definitely need good coax. Now, when you're talking about using a BNC cable and going to a radio with an SMA port, make sure you get the style of SMA to BNC adapter here that you see here, and not the one that is crossed in a red circle here. That kind will likely destroy your SMA connector after too many times. So make sure to get one that seats into the base of the connector so that you don't damage the SMA connector on your radio if you're going to be using it. And I would not recommend using SMA cables. Always, if you have an SMA HT that you want to use, put a BNC to SMA adapter on it and use an adapter and use BNC on your cables. SMA is too fiddly and it comes loose. It's those cables flexing around are going to put strain on that tiny little connector. These single part BNC to SMA connectors really do offer some strain relief, and will save your fragile SMA connector. So what other equipment do you need? Well, there's some other things that you might need. You're going to need to find the satellite. So you're going to need a way to track satellites. Generally, you can use your phone. You're going to need headphones. if you don't use headphones in your full duplex, you're going to feedback. So you need to use headphones with your radio, and also you might want to use a voice recorder. It's very difficult to hold a radio, hold an antenna, look at the phone, and also log your contacts. So what's very helpful is to record your passes on an audio recorder, and then just listen to your listen to the pass and log log off that. All right. Take a breather here and see if there's any questions before I move on. Covered a lot here.
Yes, there is a question.
Okay.
Any thoughts on the ARRL dual band 2 meter 70 centimeter handheld Yagi? Apparently they're selling it for $100.
Yeah. Again, I've never used one, but it's I believe it's what 2 elements, and how many elements is it on 70 centimeters?
I don't know. Let me look it up.
Yeah, I mean, it should work as well as any other. I don't have any reason that it won't. But here's the downside: it's only 3 elements on 70 centimeters. So that I that's really pushing it a little lower than you'd like. I we worked. So at the demo station, we were trying out a few various antennas. Of course, we used the Arrow primarily, but one of the others that we tried was it was a guy that was making. It was called the Tape Tenna. It was a guy making tape measure Yagis, and the antenna looked fine. I'm sure it worked great, and it worked pretty well. But it was only 5 elements on 70 centimeters. Whoops. Oh. I see that. Yes,
Hi, my name is Wayne Green. I am AWR.
So there's a picture.
I don't see the screen share. Let me see. Oh yeah, there it is. Never mind. I do see it. Okay. Yeah. So that is only 3 elements on 70 centimeters. So yeah, I would personally go for something with more elements on 70 centimeters. It'll get the job done, but you will not. The Arrow is 7 elements. We tried a 5 element. Again, that tape tenna that I mentioned was a 5 element Yagi, and it was noticeably. We heard the SO. What I think we're on SO50. We heard it less well than we did with the 7 elements of the Arrow. So 3 elements is even going to be down for that. Down on that. Now it is, of course, it's lower cost than an Arrow. It's going to be lighter, more compact probably, but it is not going to have as good of performance as an Arrow. Probably not as an Elk either. Again, it is. Luckily, it is cheaper, so it is something, and it is certainly better than a whip antenna or something else. But I think more elements would be better.
Okay. This question comes up every year. I should find the reference. Who makes that little SMA to BNC adapter?
Diamond. There are several. Yeah, there are others out there, but it's definitely Diamond is probably the one that is most common.
And the retailers carry those, I know. Is the ICOM IC9700 true full duplex for sure?
Yes, it absolutely is. It's a wonderful radio. Unfortunately, the price has gone up recently, so I think its retail is over $2,000 now. So it is not a inexpensive radio, but it will do everything you need to do for satellites. But yeah.
Hey, not as much as a new heat pump.
Well, no, that's true. Yeah, it's a fantastic radio. It was even better at the original price of around. I think at one point they were going as low as $15.99, but They started out around 1900, dropped down to 1599, and now shot back up to over $2,000, I think. Although I think there's some I think you can probably get it less than that, um, but the ICOM 910 as well is still a great radio, and that is available. I see them all the time for under $1,000. So that may be the way to go as well if you don't need the newest and latest.
So one
There
more
are,
question, Paul. There's
yep.
are the half duplex radios sufficient, such as a IC 705?
No, it's not going to be sufficient, but you can pair them with another with either one of those SDRs or
Right.
or another radio that you happen to have
That's
that's
what you're
also does
talking
half
about
duplex.
at the beginning of the presentation. You got to
Yes.
have either a pairing or full duplex. Okay.
It's very helpful to be full duplex. We never recommend that you try it half duplex. It's a recipe for frustration, and it can cause well, if you're transmitting, somebody else is transmitting over you, you would have no idea, and you're just going to be interfering with each other. If two half duplex users are transmitting at the same time, they have no idea they're interfering with each other. So it's really I have made my share of half duplex satellite QSOs. It is possible. A lot of people do it. It's not a recommend. It's not recommended.
Okay, back to you.
All right. All right, so now that you have your equipment, you have your radio, your antenna, your coax, now we need to find out where the satellites are. So satellite tracking applications provide some critical information. First of all, the acquisition of signal, time, and azimuth, and we'll get to these questions on the next, the definitions of these terms on the next slide. The time of closest approach, time, azimuth, and elevation, and then the loss of signal, time, and azimuth. They also generally provide a graphical representation of the satellite path and often the satellite's footprint over the Earth. So this shows you everything you need to know about where the satellite is, when it's coming over, when it's going to be close to, when you're going to lose it, and who you can communicate with, what areas you can communicate with while the satellite is above the horizon. A lot of this software includes both radio and rotor control for base stations. But again, you don't need any of this software right away. You can look up satellite passes on our website, on AMSAT's website, amsat.org/track. N2YO.com also has great real-time online satellite tracking. If you're in the DC area, especially if you're a PVRC member, Chip lives in Maryland and is a PVRC member. So he's provides a great resource there. There's also a number of other websites, Heavens Above. I can't go through all of them. There are also there are a number of apps for phones. Probably the best, and I should have replaced AMSAT Droid Free with Heavens Above. AMSAT Droid Free no longer works on current versions of Android. But if anybody's an Android developer, it is open source, and there was actually somebody who asked me about porting it to newer versions of Android this past weekend, but that is outside of my expertise. It's an open source. It was written by one of the AMSAT UK people, and he's no longer doing Android development, so he just made the source open, but he just made it open source. But there is it doesn't work on current versions of Android. Satellite Tracker is a great program for the iPhone. It's the one I use the most often. It's just called Satellite Tracker by VOSWorks, who I think is WOVOS, W0VOS, and that is a really good program. The other great one is Go SatWatch for the iPhone. Again, both these are excellent. ISS Detector. These are all going to be paid apps. ISS Detector is free if you just want the ISS, but if you want amateur radio satellites, it requires a payment for that. Heavens Above, I believe, is the same way, and there's a number of others. Everybody has their own that they like, so I can't cover them all in this presentation. So Windows gold standard for satellite tracking is going to be SAP PC32. It is old looking app. It was written in the 1990s. It still works. It's being updated with modern some new features, but it still retains the 1990s UI, which is a negative about it. But it does everything that satellite operators need, and most probably most of the satellite operators that are most active still use SAP PC32. It's worth it if you're going to be driving. If you're going to be driving a home station, it also has excellent features for determining co-visibility of passes, as well as so determining if you have a window with another station that you want to work, and generating lists of passes for the next week or so. It has some good features for that. If you're a Mac OS user, Mac Doppler is a great program. It has a great interface. It does everything that's needed as well. Linux, there's gpredict, and now it seems there's every day somebody else is coming out with a new program. There's things like, I think, Skyroof, and there's a whole bunch of different programs coming out. One of the things, not to get too far into an aside, but there is a lot of amateur radio software development going on now, especially through the use of a lot of the authors are using AI tools to code some really excellent stuff. And there's a lot of new ideas, a lot of different options now for all of this stuff out there. There's just a ton of options, and certainly find one you like, and all of them essentially use the same. All of them essentially use the same calculation methods to determine when the satellites are going to be passing over. They all use the same routines. So none are going to be more accurate than another, but it's all about user interface, features that are needed, and just the overall look. So find one you like and use it. They're all going to show you the same numbers. All right. So I know I've used a lot of terminology in this presentation so far, and we're going to talk about some of that. So when we talk about a satellite, when we talk about a satellite pass, the time a satellite is visible to a ground station is called a satellite pass. During the pass, you are in its footprint or the line of sight of the satellite. The altitude of the satellite above Earth determines the length of the pass or time on station. This can be between 4 and 12 minutes for some of our satellites that are in higher orbits. That could be up to 20, even 22 minutes for a good pass of RS-44. So now you see on the graphic here, you have the different, a person there holding an antenna. You see the acquisition of signals when it comes over the horizon. Time of closest approach is when the satellite is closer to you, and then loss of signal is when the satellite goes below the horizon. So when you think about satellite frequencies, we can't just say the transmit frequency or receive frequency, because the frequency you transmit on is going to be the received frequency of the satellite and vice versa. So to eliminate confusion, we use the terms uplink and downlink. Uplink is going to be frequency or information going to the satellite, and the downlink is going to be the frequency or information coming from the satellite. So when we talk about satellites, when we do satellite communications, amateur satellite communications, one of the more challenging aspects of it is dealing with the Doppler effect. The Doppler effect is the apparent change in the frequency of the radio signal due to the increasing or decreasing distance between the ground station and the satellite. Again, it's a similar concept of a train whistle. When a satellite approaches you, it's going to be at a higher pitch so it's going to show at the higher nominal frequency, higher than the nominal frequency. So you're going to receive its signals at a higher frequency than would be listed as the center frequency. When the satellite's closest to you as it's going to be at that listed nominal frequency, and then it's going to gradually get lower on the frequency. Now, generally with satellites that transmit on UHF, we usually can leave, especially FM satellites, we can we can leave the VHF frequency alone. For most satellites in a low Earth orbit, the total Doppler shift on FM is or on VHF is plus or minus 3 to 3.5 kilohertz. For 2 meters, that's again for FM. That's generally within the FM pass band, so you don't really need to adjust your VHF frequency all that much or at all. So on UHF downlinks, we do have to adjust the downlink so that the signal you receive is on frequency, and you'll hear it fade and come in and then fade out as it drifts past. When you're transmitting on UHF and receiving on VHF, it's a little more complicated because you don't necessarily know exactly when to adjust your uplink. So the signal is received by the satellite on the design frequency, but you can listen to the satellite on the same frequency. So that's just a complication that we have to deal with satellites. They're traveling very fast, and as they approach, their frequencies are going to be shifted. So on UHF, VHF satellites, again, you must adjust your uplink frequency. There aren't any that are really active at the moment. AO91 is active every couple of days. I kind of removed it from this. I did remove it from this presentation because it's not often active. PO101 is also not active too often these days, but with all these satellites, you do need to adjust your uplink frequency so that your signal arrives at the satellite on the design uplink frequency. So basically, you have to tune your transmitter and transmit 10 kilohertz below where the satellite's center frequency at your acquisition of signal, and then shift down and shift to transmitting above as the satellite's departing, because the Doppler shift is going to be the opposite for what you would do if you were receiving that signal. So it is a complication there, but you get used to it. It does. This all does take practice, as I will mention later. All right. So on VU satellites, you adjust your downlink frequency so the signal you receive is on the frequency on frequency. So this is a little easier because you're going to hear it, right? So you start listening for UHF downlink at 10 kilohertz above your center frequency, and then continue to tune down as you as the satellite passes over. All right.
Oh, there's software that can do this for you too, right?
Absolutely, but I mean, if all like SatPC32 and MacDoppler, GPredict, they'll all show you the frequencies. There are some phone apps that'll show you the frequencies as well. But if you're using FM satellites with a handheld, you're going to have to tune it manually. They don't really have any computer control capabilities, and you wouldn't generally use that. It's generally not necessary to computer control for FM, and you can just kind of tune the knob. But yeah, a lot of people will program in. No.
I think we
Okay,
lost.
there we go.
There
Yeah, sorry.
You pull your microphone cable out.
Yeah, hold on. Can you hear me?
Yes, we hear you.
Okay, all right. Sorry about that. I accidentally was adjusting my AirPod and pressed the mute button. All right. Let me get back to the slide here. So generally with FM satellites, you're really not going to be utilizing software. Most people program memories so that you have them all in your memories. So you just tune between the various memories for during a pass, or you can just use the VFOs. All right. So let's talk about are there any other questions?
Nope, that was it.
Okay. And does anybody want to take a quick break before we finish, or are we going to go all the way through till the end of this?
How much longer do you have?
Probably about 20 minutes or so.
Perfect. Point. Keep going.
Okay.
If you're up to it, we'll.
Yep. No problem. All right. Okay. So what So now let's talk about what frequencies satellites are on. So because satellites are small, and I have a model of, let's see if I can get it in the, see if I can get it into, there we go. So this is an actual size 3D printed model of a 1 unit CubeSat. 1U or a 1 unit or 1U CubeSat is 10 centimeters by 10 centimeters by 10 centimeters, or about 4 inches by 4 inches by 4 inches. It's very small. There's not a lot of room for different electronics. For electronics, batteries, solar cells, everything that goes into the satellite has to fit in that 10 centimeter cube. So I'm sure many of you may have seen repeater sites or been at Hamfest and seen duplexers for 2 meters. You see that they are very, very big. So in order to both transmit and receive signals at the same time, amateur radio satellites, certainly being so small, need to operate crossband, which means the uplink to the satellite is going to be on a different band than the downlink from the satellite. The more common ones that we've had in the most common one right now is what's called mode VU. It's also mode J for historical reasons, being that it was first used by a Japanese transponder, so it's mode J. But you will hear both. You'll hear VU mode J, or you'll just hear 2 meters 70 centimeters. But that is 2 meter uplink and a 70 centimeter downlink. By convention, the first, if you're looking at these modes, U/V, V/U, by convention, the first band is going to be your uplink band. U being 70 centimeters, V being 2 meters, then L being 23 centimeters. And we did have a few years ago a satellite that had a L/V, so it's 23 centimeter uplink, 2 meter downlink. And to make it even more obvious, by convention, AMSAT uses a lowercase letter for the second letter, lowercase being for down, I guess, uppercase being up, lowercase being down. So that is another trick that we use, although not everybody follows that convention. We try to stick to it in our materials. So again, most of the satellites that are in operation right now have 2 meter uplinks, 70 centimeter downlinks, but there are also a few that have 70 centimeter uplinks and 2 meter downlinks. There are no two-way satellites at the moment that use any other frequency combination, unless you want to count CatSat, which is a 5 gigahertz uplink and a 10 gigahertz downlink. I don't believe a contact's been made on it yet, but transponders has been tested, and it's kind of cool, but not many people have the equipment to do that. All right, so satellite frequency allocation. Now, satellite bands are the amateur satellite service is technically defined as a separate radio service from the amateur radio service. There's the amateur service and the amateur satellite service. Satellites are limited to amateur satellite service bands. So it is you will not see, for example, we hear people that talk about wanting satellites on 6 meters or 222. You'll never see satellites on that band because it's not legal. Those bands are not allocated to the amateur satellite service. You cannot have satellites on those bands. Additionally, on 70 centimeters, for example, 435 to 438 megahertz is the amateur satellite service allocation. No satellites can be outside of those 3 megahertz of spectrum. On 2 meters, legally, all of 144 to 146 is okay, but the band plan only includes 200 kilohertz because 2 meters is a very crowded band. So essentially, all of your satellites on 2 meters are going to be between 145.8 to 146 megahertz, and then again, 435 to 438 megahertz. Now, there are additional allocations in these other bands, which are L is again 23 centimeters, S is 2.4 gigahertz, C is 5.6 gigahertz, X is 10 gigahertz. I think K is 24 gigahertz. I guess Q is 47 and W is 70. Is it 73 or 77? I forget. But there are amateur satellite allocations in there. The highest that has ever been used by an amateur satellite is 24 gigahertz, which was used on AO40. But there's never been a 47 or 70. Forget if it's 73 or 77, but again, we'll see. Maybe one day somebody will put something up there. Maybe one day we will. All right. So let's meet the FM satellites. Again, FM satellites are essentially repeaters in space, and so they're considered easy to use because they are FM repeaters, and that is a little less. Uh, uh, they're easier to use than a linear transponder, where you're a single sideband and CW. First of all, they're more expensive because the transceivers are more expensive to do single sideband and CW on 2 meters and 70 centimeters, and Doppler shift comes more into play for those as well. So FM satellites are considered like the easy sats because they are easy to hear, easy to work, easy to aim your antenna, easy on the credit and easy on the credit card. We do have an updated list on amsat.org of the FM satellites, but we're just going to highlight a couple here. The first one that I do want to highlight because it's easiest to hear is the repeater on the ISS. This is a modified Kenwood TMD710GA located in the Columbus module of the ISS. It normally is running with 10 watts of output power, which is 40 times more powerful than SO50, which we'll talk about next, which has a 250 milliwatt downlink. It does have a mode VU FM repeater. It's available most of the time, except during school contacts and EVA or docking maneuvers. Its uplink is at 145.990 megahertz, and you do need a 67 hertz tone programmed in, enabled to get through to that repeater. The downlink is on 437.800 megahertz, which means that you will need to tune starting at 437.81 and then tune down, and at your loss of signal, you're going to be down to 437.790. Now, because ISS is so easy to hear, it's extremely popular, and it's very, very crowded. But certainly, if you haven't heard a satellite before, I'm pretty sure you'll be able to hear the ISS repeater. That 10-watt signal is very strong. Even with a stock rubber ducky, you should be able to hear part of a decent pass. Better rubber duck, you may hear the entire pass. So again, listen for the ISS tonight. I know, again, this I apologize for those of you out of the area, but the session did kind of originate in DC area, so I do have the DC area predictions. The ISS will pass over this area from about 10:03 p.m. to 10:13 p.m. That's a 27-degree pass to the northeast, and it may actually be partially visible during that time. So you may see it briefly, but it won't be that bright at that time of day. It's I think the magnitude was I forget what the magnitude was. It wasn't going to be that bright, but you may actually be able to see it. Although actually looking out here, you're not going to be able to see it in the DC area right now tonight. But yeah, certainly if you're able to go out and listen to it, I know it's raining, but if you're able to be under cover or anything, certainly listen for it. You will certainly hear it. A 27-degree pass is a pretty good pass. And later in the evening, then that's going to be starting out of your northwest and going down and setting to about due east. If you missed that one at 11:39 p.m., it'll be going starting out to the west northwest and going south and setting south southeast, and that's a even higher pass at 35 degrees. You should be able to hear it with just a whip antenna if you go out and listen for it, if you haven't listened to a satellite before.
I would just say be patient. I've done this, and usually you don't hear it until it's pretty high up. So at least, a third of the way into the pass.
Yeah, I mean that all depends on your surroundings. If you're in that rural area with not many trees or anything, you should be able to hear it even lower than that. Even with a stock whip, maybe not, but with something like a longer whip, it generally is fairly audible.
But I'm just saying, don't give up because it's
No.
just 2 or 3 minutes. Stay for the duration of the pass, and you should be able to hear them.
Yes. Yeah, and there's always the chance that nobody will be transmitting. It does. I forget how often it transmits a beacon. I guess every 10 minutes, so you may hear a beacon. But yeah. So. But also, and it won't happen tonight because it's too late for the astronauts. But the astronauts can actually can actually pick up the microphone and transmit just like they are on the repeater. So, and most random contacts that have happened with astronauts recently have been using that functionality. So it's they can just join in on the action whenever they want. Of course, for passes at this time, they will be sound asleep. But I don't know if there have been any random contacts recently, but depends on the astronauts that are up there. But they do have the ability to just pick up that microphone and use that repeater whenever they'd have a spare moment. All right. The next satellite we're going to talk to is kind of on the other end of the spectrum for how audible it is. This is SO50. It is by far our most reliable and long-lasting FM satellite. It has never been offline. It launched on December 2nd, 2002. It has a 145.85 megahertz uplink and a 436.795 megahertz downlink. But that downlink is only at 250 milliwatts. So your receive system does come into play. You do need a 67 hertz tone on the uplink to access it. And also for the repeater to be enabled, it needs to hear a 74.4 hertz tone for at least 2 seconds to be turned on. So sometimes it'll go off in the middle of a pass and you have to switch your tone and press the button for it to come back, transmit that 74.4 hertz tone. Now, the fact that it has a 250 milliwatt downlink in a relatively large satellite, it's a microsat, so it's bigger than a normal CubeSat. It is, and the fact that it only stays on for 10 minutes unless it hears that specific 74.4 hertz tone certainly has contributed to its longevity because it is the batteries don't discharge much. Given that it only transmits 250 milliwatts and only is transmitting when people are actively using it and intentionally using it because it requires 2 tones to get to. So that is a key to why it has lasted 23 years and counting now. Again, it has always been there. We'll see how long that lasts, but it has not gone offline in 24 years, 23 years. There are other FM satellites up there. AO123 works great, but it is only active periodically. Check amsat.org/status for to see if any of these satellites are on. RS-95S, or also known as QMR QWT2, is also a pretty good repeater satellite. It was active this past weekend, but it is only active periodically. They do announce that on X. Then there's a constellation called the Tevel 2 constellation. We had kind of given up on them. They were briefly active last year. There's actually 9 satellites in this constellation, always sharing the same uplink and downlink, all with FM repeaters on them. Only 2 of the FM repeaters have been active, and they were active last week. I actually haven't seen if they're still active. I don't think so, but they're worth checking out as well when they are when they're active. But yes, it looks like they have not been active since this this past weekend. So anyway, again, all these are good satellites, and they just aren't on all the time. All right. So how do you track a satellite? Well, low Earth orbit satellites will travel in an arc in relationship to your location. The best thing to do is to ID your AOS azimuth, your acquisition of signal, your time of closest approach azimuth, and max elevation, and then your loss of signal azimuth. And sweep. Just note that it's good to note like various features that your looking on like trees or houses or something, point out, okay, that house is right where the satellite's going to be. And that house is right where the satellite's going to be when it sets below the horizon. And then during the pass, you're going to sweep to find it, and you may need to vary your antenna polarization as well, because as the satellite is traveling in relation to your antenna, you may be cross polarized. And listen for the strongest signal and just keep tracking it. Hold on to that signal. Note that your azimuth elevation is provided in relation to true north, not magnetic north. So keep that in mind if you're using a compass. As I mentioned, you do have to match the polarity of your antenna with that satellite, because the better the match, the stronger the signal. Technically, a linear mismatch will result in a loss between 0 degrees, 0 decibels, which is a perfect match of your polarity, to about 20 decibels, which is 90 degrees out of phase. Technically, it's infinite, but it's usually in practice about 20 dBs. So if you're off polarity, you're going to lose quite a bit of signal, especially if the signals are already weak, like SO50. You're potentially going to lose reception completely if you don't continue to match the polarity of the antenna with that of the satellite. Satellites are continuously tumbling or rotating in orbit, so you do have to kind of constantly twist your antenna for polarity. Now, if you're using a home station with circular polarized antennas, you're good, but if you're using any sort of linear antenna, you're going to have those polarity mismatches unless you're able to adjust it. That's why we don't generally recommend using an arrow on a tripod unless you have a way to, and there's some people who've built these mounts that you can just kind of quickly adjust the polarity of the arrow while you're sweeping it on a tripod. All right, during a QSO on an FM satellite, you're going to want to be clear and concise and use standard phonetics. So say I hear N9IP, I'm going to say N9IP, November 8 Hotel Mike, Fox Mike 18, and they're going to come back and say, November 8 Hotel Mike, this is N9IP, Echo November 60 QSL, and then you just call back and say QSL and NHM. That is a complete satellite QSO. You usually don't exchange signal reports. You're going to exchange your grid square. Don't call CQ on an FM satellite, but if you don't hear anybody, if it's quiet or nobody's talking, you can just say your call sign and grid square. All right. So to work a pass, you're going to prepare by programming your radio with the correct satellite frequencies and your tones. Use headphones to minimize feedback and enhance your ability to hear. Have the ability to record satellite pass audio so you can log and review it, so you can listen to yourself and listen to the pass and see what you missed. Pick a satellite to work, know its frequencies, recall the strategy for dealing with Doppler effect, fix the lower frequency and adjust the higher frequency, and pick a location where you have the clear or best view of the horizon that you can get. That is important so you can see as much of the pass as possible. Then you're going to want to verify your acquisition of signal, your time of closest approach, and the loss of signal, azimuth and times. Now, it's very important when working an FM satellite to open your radio squelch. Most of the time, the satellites are not going to be strong enough to break your squelch, so you want to keep your squelch open. And then tune your receive or transmit frequency to the acquisition of signal frequency. Start your recorder, listen to the satellite. Now, if you're new to this, you should not transmit until you've heard the satellite and you're solidly hearing the satellite. You want to make sure that, again, you do not have that your equipment is working properly, that you're able to hear the satellite. Now, once you get more experience doing this, you're going to know, okay, I know my equipment's working. I'm not quite hearing anybody yet. And then you can kind of put out a call, see if anybody's out there. Especially if it's like SO50 at 3:30 in the morning or something like that, there may not be anybody on. So you may have to turn on that timer with the 74 hertz tone, 74.4 hertz tone, and then it's your call sign and see if you can hear it. Now, actually, those late night passes are great for testing because there aren't that many people on. You can transmit and see if you can hear your own signal well and kind of just test that from horizon to horizon. All right. So when you hear others, listen for a call sign, and when that break occurs, a break in the signals occurs, make your call. November 9, India Papa. November 8, Hotel Mike, Fox Mike 18, and then complete the QSO. Again, it's generally it's the best practice instead of just throwing your call out to call somebody. That way, the other person knows that you can hear and will call you back. Uh, Sometimes there are some people who will just throw their call signs out on FM satellites and not, they can't hear. So people call them and they're not responding. So what happens among some more experienced satellite operators is when they just hear somebody throwing out their call sign, they may suspect that somebody is not actually receiving the satellite and they may not get a response. So the best thing to do is to identify somebody that you want to call on the satellite and call them directly rather than just throwing out your call sign. All right. So how many hands does this take? Well, there is a lot of stuff that has to happen all at the same time. You're going to track the satellite with your antenna. You're going to twist your antenna for the strongest polarization. Your frequency is going to change for the Doppler effect. You're going to have to listen for call signs and locations, push the push to talk button, talk, listen, and remember who you talk to. Don't panic, breathe. You got this. Again, this takes some practice. I do not expect to go out, get on a pass, make a bunch of contacts your first pass. Now you might be able to, I'm sure, you certainly can, but a lot of times you're not gonna hear something, you're gonna have something missing, you're gonna be missing something, you're not gonna hear the satellite, you're not gonna be able to get into the pass, you're not gonna quite understand what's going on. Um, my recommendation is just to start listening to passes. Practice hearing it, get a feel for the polarization changes, get a better understanding of the Doppler effect, get a sense of that QSO rhythm and techniques, and spot the bad operators. Learn from their mistakes. You will hear people that are just constantly calling over others, or maybe calling every single person on the satellite, or not listening to what's going on, that sort of thing. So listen for that. Learn from their mistakes. Listen to 2-3 passes before you try to jump in and start transmitting. You'll be a much it'll be a much better. It'll be much better. You'll have much more chance of success once you. Again, the hardest thing to do is hearing and understanding what's going on the satellite. So once you do that, you'll be able to find those dead spots where you can get your call sign in and make those QSOs. Because again, it is a repeater, a few hundred kilometers up there. There's a lot of people within the footprint. There's often a lot of different people trying to call and trying to make contacts. So it can be a challenge to get through. If you listen to everybody's timing and stuff, you'll identify and you'll figure out when to call to maximize your chances at making a contact. All right. Again, we've gone over all this, but use a small directional beam, clear of obstructions. Use the least power necessary to complete the contact. Set your transmit and receive frequencies and memories to make tuning easy. Select the tone. Often, for most satellites right now, it's 67 hertz, but that may vary by satellite. For receive, open your squelch all the way. Use headphones or earbuds. Use a printout smartphone, tablet, or laptop to track the satellite pass. Use the audio recorder to log a QSO, and twist your antenna as the pass progresses for the best received signal. All right, so we're getting to the end of this presentation here. So for more information, we do have an excellent resource. Getting Started with Amateur Satellites covers all these different topics, and it covers more. It covers linear transponders, digital. It covers all aspects of this. A digital download or a print copy are available on the MSAT website. The digital download is $15, but it is currently being offered for free with new or renewed AMSAT membership. So if you're not a member, join AMSAT. It's a great resource, updated regularly with new information. And again, you can either download that for $15 or join AMSAT and get a free copy. There's also an older series of articles. I think it was from back in maybe 2019, 2020, this was written. It's a collection of articles that was in the AMSAT journal, and it's for beginners amateur satellite primer, written by Keith Baker, KP1SF, and we have that available on our website as well. It's not nearly as comprehensive as the Getting Started Guide, but we do have it available for free on our website. I would certainly encourage you to check that out. All right. Are there any questions? I know I covered a lot and probably very fast, but that still took
Of course,
an hour and 20 minutes.
of course, there are questions.
Yes.
I've got a handful here, so let me go through some of them. Are there any HTs, or I'll broaden it out. Are there any radios generally that automatically compensate for Doppler effect?
So, great question. The new Anytone ATD890UV does have that satellite mode. First, you have to use the CPS software to get the caps on the radio. And the downside is at this point that it doesn't operate in full duplex. No, the radio is capable of operating in full duplex, but the satellite tracking routine has basically been ported over from the older non-full duplex models like the 878. So it doesn't actually enable the full duplex mode when it's in that mode. So it's really frustrating that feature is not available. Hopefully they'll make a firmware update that does that. But as of right now, yes, it will track the Doppler shift, but it will not enable full duplex, which is really a shame.
And which model was that? The Anytone 890?
Yes, the ATD D890UV. I think I don't think the 878 has it anymore. I think they ran out of room and took the feature out. But the ATD 890UV has that satellite tracking feature, and it's full duplex, but both don't work together, which is again frustrating.
You can operate full duplex, or you can have the Doppler compensation.
Right. Hopefully they'll be able to make a firmware update that allows you to do both, because then it would be a great FM satellite radio.
Right. Someone else asked that actual question. Said, "What about the Anytone 890?" So there's your feedback on that too.
Yeah.
So I've got a participant. One of the guys, Brian N6UGP, says that auto frequency shift is a feature of the OpenGD 77 firmware for many DMR radios too.
Mm-hmm. That's correct. Yes.
I'm gonna copy that comment into the chat for everyone so everybody can see what I just said. Thanks, Brian. How about egg beater antennas for a fixed station?
Generally, especially if you get something like I forget how much the M² egg beater antennas are going for now, but they're quite
$400.
Yeah, they're quite pricey, and you would do better with a TV rotor and a couple of Yagis, or just even something that there's a couple of dual band Yagis that are small, basically the size of an arrow, that are designed for permanent installation. One of those on something like a TV rotator, angled up at 15 to 20 degrees, is going to outperform the egg beaters. I would recommend against the egg beaters for making satellite QSOs. There are again better alternatives. Now there are people that have done extremely well with them. Generally, they're in low noise areas. There's a guy up in I think he's in outside of Marquette, in really in quite a place that's not close to much of anything. He always shows pictures of his egg beaters in the snow, a ton of snow in the winter, on the AMSAT Facebook group, and he does very well with those egg beaters. But there aren't many neighbors around him, so he has very low noise and can get away with those that omnidirectional pattern. But for the cost, unless you were to build your own, and that's complicated, but for the cost of the M² egg beaters, you're going to be far ahead with a small dual band Yagi on a TV rotator, angled up at 15 to 20 degrees, and then even manually controlling that
And
rotator.
then could you have a computer control that rotator?
Again, that depends on the rotator. I mean, there are obviously. I'm talking about using a very cheap TV rotator that likely
So if
doesn't
you
have a
have the
computer
cheap
interface.
TV
But
rotator,
yeah,
you just turn it yourself, or
right,
adjust the rotator controller as the satellite passes over.
right. You do not need an azimuth and elevation rotor. Azimuth and elevation rotors are quite expensive. Uh, uh, there are a few that are available for small antennas now and for more portable operation. But obviously, something like a G5500, I forget how much they cost now, but they're expensive just for the rotator, let alone the antennas and the feed line for all of that. So if you
Interface.
do want to if you are looking for a low cost fixed station, which if you're talking about egg beaters, you probably are looking for a low cost station. Again, you'd be better off with a Yagi. And again, angle at about 15 to 20 degrees. I don't know if that page, unfortunately, Bob Berninga, WB4APR, passed away a few years ago now, and he had a bunch of information on his website, and he did an analysis of low Earth orbit satellites and showed exactly why you're not going to miss much by having a Yagi fixed at between 15 and 20 degrees. On an azimuth only rotator.
Let me see if he's still. No, I don't see his web page anywhere. I'll look for that. Let's see a couple more questions. How could quote unquote mere mortals get involved in helping to build amateur satellites?
Oh, that's a great question. AMSAT is always looking for people that have engineering experience or really experience in many different fields. Even if you don't have any engineering experience, uh, well, we're always looking for mechanical engineers, electronics engineers, um, all sorts of other software engineers, of course, to write the code for the satellites.
So
People that
call
can do
you, huh?
thermal engineering, but any other discipline as well. I mean, I'm not an engineer, but there are people that need to there are needs for things like website work and revising the getting started guide and doing things like that. So email info@amsat.org if you're interested in volunteering. Explain what you'd like to do and what your knowledge base is, and somebody will get back to you with information about that.
amsat.org.
Yes,
Got
yes,
put it in
yep,
the chat.
yep.
And I think one more. You talked about the I forget what the designation was for the satellite that's been up for 20 some odd years, where you need dual tones.
Mhm.
How do you do that? Was there special hardware or software or?
Oh, yeah. Sorry. I need to make that clear. Don't do two tones at once. It's use you ha to access the satellite. You need a 67 hertz tone. You need to transmit that 67 hertz tone to communicate through the satellite. To essentially, you're sending a command. The 74 hertz tone is just a carrier with a 74 hertz tone, 2 seconds, 74.4 hertz tone for 2 seconds, and that turns the satellite on. You're not transmitting both 67 and 74.4 hertz at the same time because, yeah, that wouldn't be possible with your basic FM
Right.
transceiver.
So do you send the 74 just with a carrier initially, or?
Yeah, you don't need to. I mean, you could announce your call sign, but it won't be repeated through the satellite through the satellite anyway. So it doesn't it does yeah, you would just transmit a carrier at 74.4
Okay.
hertz for two
And you should
seconds, and it'll turn it
identify, of
on.
course. And then you switch your.
That's actually, if you want to go by the rules, it's telecommanding a satellite does not require identification. So then that would be sending it a
Oh,
command.
so the 74 is a telecommand, so you don't need. Oh, interesting.
Yeah. If you want to get technical, I mean, yeah, if you technically by the rules, you
And then
don't
you
need to have
switch
any.
over to the 67 hertz tone
Yes.
after you light it up. Okay.
Yep. Now, in most cases, especially if you're on a pass in during uh, prime hours here, you're or on the
Somebody's
East Coast,
already
you're never gonna need to turn it
somebody's already
on. So,
done that.
yeah,
Gotcha.
yeah.
All right.
But it's good, and you'll find on the programming guides uh, uh, for different satellites and how to program your HTs memories for them. And a lot of time it'll have an SO50 on, which is just 145.85 with a 74 hertz tone instead of a 67 hertz tone. It's a good idea to put it in your memories if you're going to use memories.
Okay. Good timing. Midway through the evening, a good time. I know you can use a break
Yes.
to go lubricate the throat. There you go.
Yeah.
Let me stop the recording, and then we can start a new one